world. Everybody hear me? And that's great. Hello, PyCon Axim. It is so wonderful to be here. I've been here 3 days now, and I love the work. It's so nice to see so many people here excited about it. A little bit about me. That's a pretty old picture of me. Here's the more recent one. That's from 24 hours ago. My name is McCormick, and I'm an avid Python programmer. I've been programming Python for over 10 years now, using it professionally, also using it as a hobbyist and for just personal tooling. Really, it's my language of choice. I love Python because it has a simple core language at the base that is dynamically malleable, but on top of it, you can use so much. You can use better programs to build just frameworks, and you can use static analysis tooling on top of it to add all structures. And just what the editor is really unique and special about that. And on top of all that, it's readable. It's easy to learn. I can cross it where the asked letter on the old data structures. And on the data project, I'm a core contributor as well as a maintainer. And I like to ask sometimes, what's it like maintaining an open source project professionally full time? And it's rewarding, it's fun, it's challenging, but more than anything else, I think it's a bit chaotic. And I don't mean that in a bad way. Chaos is good. Here's a picture from one of our OpenEdit talks from a few years ago, where we had a team of contributors from around the world, people who deploy OpenEdit, people who build OpenEdit, hundreds of contributors to the project. And of those contributors, we have about 65 who are core contributors, people who have direct access to change some part of the project, often the core coders. So with all that collaboration going on and all those different ideas and perspectives, use cases, and working groups we have where we divide operating problems, it can feel chaotic, you know? There's a lot of different ways that people use the software. Some people want to use it for larger websites, some people want to use it for more like focused single cloud installations. And often there's you have to balance different needs perspectives. You do have a process called OS, OpenEdit proposals, inspired by artifacts, Python NST proposals. Below is 256 calories on what added one up. It's a lot. So chaos can be good, except when it's not. You know, for all this collaboration, there's a lot of code in it. In fact, there's over 220 repositories that are already new about those projects. Over half was required in order to run base installations away. And each of those repositories has its requirements, a list of other dependencies that must be installed. And each of those repositories has issues, it has pull requests that may be attention to. And this is just the upstream for providing. People who deploy OpenEdit have their own ports as well. So there's a lot to be corrected. And all of those need upgrades and other fixes, need to be and stage jump to make them. And that's things maintainers have to do. If you're deploying OpenEdit, all of these repositories factor into configuration, building, and deployment of the software. So where's our progress? I'd like to talk about finding order in all these guys. Quality, large Python projects, source efforts, and maintaining delivery. So when I think about making a project work coherent, I think about dependency. So this is a very simple framework using with that. Nodes here are called packages, but it might get them as like Python files or modules or more complex systems, maybe packages that are almost filled out. They can even be microservices. For the purpose of this talk, it's just thinking about it as towards cloud. In these dependency graphs, upstream dependencies, things like libraries are going to be pointed downwards, things like that. So upstream package is named by the package, or upstream downstream package, any ports to row exist upstream. Let's take a simple LMS. We're going to make this as an example. Now I want to pretend that we're at C here. We're at C that's maintaining core running Python admin or the learning management system. And there are a couple of packages called StringBus. Let's say an XML processing library and a core storage library that's being called Power Organization today. Those upstream packages support us, but they're also they can be a source of bugs. They are contingency on upgrades, so if we're upgrading Python to Tetris, we can't allow it. We need those packages to be upgraded first. So those are the downsides, but there's also upsides to these being obstacle bells. They're isolated. So if our course runtime had a bunch of Python functions that it exposed to an API, and we remove one of those, we don't have to worry about XML utilities library gradients. It's something to do well. Downstreams are the compute ops. So they're impacted by changes. We can remove this function. We have to worry about what happens to the student interfacing to the interface. But ideally, if we manage our dependency related to this, right, we don't have to worry about bugs in those interfaces at once. So let's talk about that initiative. So an encoding initiative. So on the left is what we want course cards with like a history of before course that, so we can say on wherever to manage the system. And sure, coding issues are you've seen before, right? Imagine that's actually coded properly into a bunch of, garbled nonsense. And so we see this on our site, and we're looking at our system, and we say, okay, here's what we know. This is how to use student interface. Students can see that. Teachers can see the exact same bug on their set interface. But you confirm that this is not an issue with the exponent delivery library. This is not an issue with how the course coordinator works. We can remember this. Based on what we know about upstreams, downstreams, where do we need plugins? Where do we look for this?
Okay, very fast here.
And what other split? Forwards. Well, which specific package will we want to look at? For this video. What is my goal? Exactly. Course runtime. Now, it's possible to base that something and making these errors are not exactly that reality. But if our understanding of the system matches this graph and not just reality development, then the best place we can look first is the course runtime. And 9% of the time, that's where the bug is. So let's say some development is happening. Our LMS that we're growing popularity in one step, started selling courses on a course marketplace. And we decided we're going to implement this in this one package because we're good with software up to types. And we want it to be an extension of the student interface. So it's going to use data from the student interface. And it's going to, integrate some marketing data. So it's BDR marketing. It has edited these courses. And of course, the marketplace is going to sell courses and also write that data back to the course storage so that it's in sync with our course content. It's fairly musical something, okay? But here's the thing. Remember how before the package we maintained is the course runtime had 2 upstreams and downstreams? Now it has 4 upstreams and 4 downstreams. So just by that in one package. And if we go back to the bug we were just talking about, can you make the same assumption we did before? No. We have any of these packages could be targeting any of our upstreams. So, for example, if the student interface is the one actually namely the encoding, that would be in between course marketplace and course marketplace between course storage. But just read through the course. See, this is one new system we've added. The way we've added it has made it 4 times harder for us to debug a single bug. So 2 strategies of managing chaos. I think, it's suffice to say choose our 3 packages, but it's going to want to anyone saying the source of our stuff. We can minimize economic systems and ours, and we really change this over to install it. But I think the way to make those first 3 days easier is to avoid cyclic dependencies. So for folks who have, learned basic graph rate, it's like a cycle in a DAG, but maybe it's not a DAG, but a cycle in a graph is when you try to create a semantic circle of the active. And when you see that in a dependency graph or application, that's when we go with having and deliver of this previous downstreams to basically everything being upstream, every different thing and upstream. So enough boxes and arrows for now. Let's look at the between. So what would a cyclic dependency look like? So if we go right now, this is a Python and others. You'll get an import. You'll get an import error. This Python doesn't actually let you create import cycles between two modules. So Python itself is trying to stop us from doing this. It's also required like the wording site is but there's an easy way to get around this. I think most of us have done something like this, right? We look at a single dependency and we say the import into that function, and then either was going to tell us, hey, that's a single import, and you can still stick his old pilot disable in there, and we're good, right? And if you're helpful, you add a nice tone that says void circuit in import. That's not what you thought you created a circuit import. What's the best way to fix this? So when you see that sort of pattern arising, the pattern I recommend thinking back with is making an API. So two modules tell it to share an interface, so make that interface. So here in this example, we have a marketing module, we have a storage, we have a storage module, and they want to choose functions to talk about another. Instead of doing that, make an API that lets you pull and then push from data through a data gateway. So marketing now push that data to the storage API, and the storage API can then pull where those are. Now that's between two modules. You can get the same thing in packages, and it's actually easier to do because, so let's say you have two views files, right? And these files are importing from utilities files, and within the same type of. So you got to receive the circular dependency change to Python packages. You can do this either on the web. And a good way to detect that is a tool called peggy-tree tool. But it's down like a hierarchical tree of dependencies that you're packaged into this, and it will learn if there's this secular dependencies. I often see this works around by not installing the other package that it's like. So go to marketing package and the storage package, you can imagine that the storage package doesn't actually solve marketing one is dependency. But the marketing one does solve the storage. So it looks like we don't have this singular dependency, but in reality, we can just do a traditional work and mock out functions from the storage. So this is just another way of working around import cycles. It makes your listeners happier, it makes it tree happy, but it doesn't make you as developers happy. So apply the same in other use case. So make an API package that is the common dependency. If we apply that to the system we're living at before, if we remove this circular, that's like dependency, then we have a much better situation. Instead of having 4 upstream invoices on time, we actually go down to 1. And instead of having 4 downstreams, we're down to 3, which is still more expensive, but much better. This pattern, strengthening the API out and makes it dependent on another, is applicable. It's generated. So before we had implementations and extensions using one another, importing one another. And now instead we extract an API off a library and then have our implementation and our extensions both useful. So this is the same graph we were looking before, but just labeled too, to show what it is and extension what's how there, what's a library. And we can take it a step further. We could take the course marketplace and we're going to do student API configuration. And from that work we've done to make the course marketplace more maintainable of that course cycle, we can make it easier for ourselves to now make it doing it. We can now get an analytics dashboard that's based on the same API and build the work with us. And if you take those and you move them, you then know that these layers. We have our core applications. Everything starts out as a core app. When you start making an application, it's the whole thing. It's also the core. These are critical to your application. And they're easy to develop in that you just kind of naturally start making them. But the rights being the same. There are a lot of business logic. There are some layers of logic throughout the stack. And as we apply the API pattern, as we realize to make our Python code-based form names typical, we end up with this API layer in the column. This these are harder to develop. It's hard to take a good API. It takes thought, it takes discussion with stakeholders, and then if you go wrong, you'll end up changing the API and like voice collaborate or changing some find your dependence. But if you do it right, it is in states. These are easy to maintain because they're simple. They don't have many extra dependencies. And they allow you to make these extensions, which are not as critical to your deployment. They're not used by the collapse. They're not used by the core applications. They're managed to do that. So these ideas are easy to develop, and they should also be easy to maintain if you structure your APIs developed. So back to our list of strategies. We want to treat our upstream by the one, then another down case. Avoid single dependencies. Use the API pattern, and once we do that, we can divide our packages in this. As we create this, it can be, you'll find yourself talking with your team about what you have in mind as your project's architecture. If you don't tell anyone else, you don't tell anyone else in your company or at your organization or your open source projects, you're going to find that other people they can't even be right. They'll start, if we go back to this graph, we'll start like writing the extension that is all of one of your providers. So completely break out your set locals. So just the first thing you can do is write there. Explain yourself and cite those documents to help you get your team on board with this architecture that they go. Here's an example that the contributor commented is important for this presentation, but it's something we use at OpenEdX to kind of communicate this pattern that we're trying before confidence. And if you can document your intentions that people may not follow, but we can also use listing to make sure that any change actually is executed. So I'm going to talk about a really cool tool called Reporter. It's free and open source. It's on GitHub, and we use it after this project. Cool. It's used in Ledger. You just hit install it and start with a configuration file where you tell it to store root package. And in this case, I'm going to pretend the root package is full for. So if you want to enforce the structure that's inadequate, we can use what's called the layer contract. And the layer contract defines sets of packages that need to depend on each other in a certain direction. And it's actually flipped unfortunately, the way Goldwings are things about it versus the way that I've been talking about it. It's soft. You can imagine the things in the bottom are upstreams, and the things at the top are downstreams. So so this is telling your core libraries cannot be imported from core apps, and those cannot be imported. And if you run that and your code base respects other rules, then look at the rules. And if someone has an importer from, for example, like 4 applications into the exception, then you'll see that in your stack. And it'll actually, your module will tell you. It'll say, hey, course cloud from the core apps, not otherwise it for core cloud of other solutions. How do we use it in OpenEdX? We have this package called OpenEdX Render that we use essentially this exact same architecture. We use a layer. So why did the layers be slightly different for this instead, but it's the same handle. We also use it in edX Top 4, which is our main LMS code base, where we are, for example, here we have a set of apps that we do not want to, that should not be dependent upon by the other packages that not called API. So you make a search like that. And then you also, it is because you start using keyboard linter, you'll find that there are a lot of violations of this. It's not easy to just take an architectural idea and apply it to a quickly scoring. So you can tell it to the newer certain nodes. We just allow this things that say, we know this does not follow our architecture now, but it will eventually be lowered. Back to our strategies. All these strategies above, the ones not folded, are essentially just tools for establishing quarterly core interactions. And so when you have a quarterly core, when you have a foundation of libraries, APIs, other packages to build upon, you'll find that it's easier to embrace chaos elsewhere. It's easier to accept that there will be experimental packages being solved to extensions, and easy to accept that people are writing extensions that are not being maintained in computers that haven't been proven yet, if you know it's not going to be a risk material for that. So when you establish order and a order project, the chaos and the extension don't feel like it anymore. They feel like life. They feel like a lively open source project. I get it. Yes.
So on here is the relations was probably you talk about outfits for building these, and then we could apply sort of the stacks, the APIs.
Yes.
Could you elaborate a little bit? Because really, I was give us a Sunday, but you need to learn about sound so that without feedback.
Yes. So this is, if you're publishing open source code, you can't guarantee that no open source to be downstream of your code. But what you can do is be explicit about what you expect and then to expect it, that it makes. So you can say, hey, this API, this is what I want you to use. This specific part of my Python project, that's what I'd like you to do downstream. So that if I for example, have a system that is writing that stack that not really used, I might want to be able to change the decision. So I don't make anything about how part of my obligation. That way, if later down the road I switch back to my SQL or Postgres, people using my downstream my packages API are not affected by that because they're not downstream of the choices I made about this.
The code that's a type. Thank you. I love to suggest bigger graphs, any large step and booked code base with relevant dependencies and that highlights how where it helps how to go. And dependencies that cause biggest cycles. By the way, we talked about the biggest cycles for the smallest. So does that even exist?
One at the biggest and the small cycles. I think it's not about the size of the cycle, it's about the enhancement of it on your ability to react against.
And can you measure this and find out which edges are, like which one would be easiest and have the most impact for your removal?
Maybe it sounds like a fascinating project for something that I do.
Do we have any other questions?
Yep. So another person used to motivate to meetings or further. So for large open projects, and especially in those company open practice, there must be a lot of people that are either too visible or open media, media testing, how their opponent is fixing for. So those kind of issues. Do they waste or are they losing better for a computer? There has to be a new one. Like what strategy does that open adapts and use to make sure that these minimize our input. And just to put some context, I also follow VLPML and their technique has been they're very interested in their review. Extremely aggressive. A bit too much. So what strategies and we just see that the currently that address what we got?
Yeah, it's a great question. So going one at a time. You asked actually I'll address the second one first. Sort of how the PPT to be introduced. I think this is where having parts of your project that you consider for libraries, just because those that's really a block triggers for this. That's where bugs have the most frequent impact to their projects. So if you're going to be really strict about reviews, dealing with it. And if you're going to be looser about reviews in order to encourage save bigger time and also to encourage more, pre-produced changes, extensions are a great place for that. And ideally, people should be able to make extensions without needing to review no pups there and changed, because if the extensions are maybe downstream, if the extensions are not going to impact the core projects, then we may trigger it at all. And I guess that is how to be your first question, and nowadays take our time. Yeah, absolutely. Issues that are filed against the repository require time to be maintained or fixed, to understand, to debug. And the setting a PDI for your projects is kind of setting expectations for others. If you don't have an API, then your entire project is to be set. If people can incorporate anyone like your Python projects, then anything step you consider the problem. You consider a regular change. But if you tell people right away, okay, I'm going to incorporate these 4 models, then that's what you have to worry about these days. If someone files a bug and says, hey, you wrote this private model that was smart API, then as a maintainer, you can decide whether to say, I'm not audible, whether to say, sorry, that's not part of the process.
Any more questions?
Yeah.
Awesome. Thank you, bye. Another question.